Hi, this is Chris Swan, CTO at Cohesive FD. I'm going to be doing a quick demo of VNS3 and how it applies to application SDN. What I'd like you to look for in this demo is our ability to span multiple data centers and vendors, have heterogeneous control where the cloud vendor runs their network and the customer runs their own network over the top, how we use cryptographic identity for the different devices and how those checksums can be compared to show peering. Our ability to separate network location from identity, and through that, the ability of the application and its owners to be in control of their addressing, protocol, topology, and security. In this demo, it's just going to be the VNS3 manager that we're showing you, so not the routing agent or any of the high-level command and control, which is coming soon. So here's our demo topology. What we've got here is a very basic three-tier application consisting of an Nginx web server as a reverse proxy at the front end, then a Sinatra app server, and then a MySQL database. And it's been gratuitously torn across 3 different clouds. And then a 4th cloud's brought into the mix to demonstrate failover of the database from one cloud to another. So the demo itself is going to be using a very simple to-do application. So let's quickly show you that there. So I can come along and I can add stuff into my to-do list. And once that's there, I can hit the delete keys and take things away. So let's begin with the web server. So this is a simple Ubuntu server running Nginx. And what I've got going on here is I've defined my upstream server as the Sinatra application server on that IP, and Sinatra's listening on its normal port of 4567. And I'm basically taking everything that goes along to this web server and forwarding it on to the Sinatra application server. So if we go back to our diagram, we can see that the connection between the Nginx web server here and the VNS3 manager and its Sinatra app server sitting behind it is over an IPsec connection. So let's quickly take a look at the VNS3 managers and how that IPsec connection has been configured. So one end of that connection is VNS3 manager, where we're pretending it's a customer site. In this case, we're actually using the cloud scaling demo environment. And so we've got the VNS3 manager in that demo environment, which is what I'm logged into here, and a single connected client. And we can see here some information about that. So the client's physical IP is 10.0.5.2, and we've given it an overlay IP here as if it was on a private LAN. Now, there's a tunnel on IPsec connecting between the subnet within cloud scaling and the subnet that we've got spread out across all of the other 3 clouds that are being used in this demo. And hence, any of the packets being sent to that 172.31 1.1 connection for the app server, or 1.5 for the app server, are being sent down that tunnel. So that's a couple of aspects of the demo already taken into account. So we can say that we're done now with the web server and IPsec. So let's take a quick look at the app server. So this app server is just running Sinatra, part of the Ruby framework. And if I do things with the to-do list, like delete our app server entry, we can see that that's going on there now in the application itself. And if I go into the application, then I can see some sort of pretty crucial elements of config going on here. So the first thing that I'd call out is static IP being used to connect to the database server. So not exactly best practice, but one of the things that we're illustrating in this demo is that we can have things hardwired to an IP, and we can cause a failover to a different thing on the same IP. And the rest of what we're seeing here in the application is all pretty straightforward. So let's take a look at some of the networking aspects of this application. So going to the VNS3 manager that I have associated with the app server, I can see that the app server itself, 1.1, is connected into this manager, which has numbered 1, and we can also see there the physical IP for it. If I scroll down a little bit further, we can see the other end of the IPsec tunnel that we had coming over from the web server. The other thing I can see in this status page is I've got my database server connected into the overlay, and at the moment that's connected to manager number 2. This is a good chance to kind of show off how the peering is set up. So I can see here that I've got another couple of managers connected into my overlay, and I can also see that I've got a topology checksum and a key set checksum applying to this particular peering arrangement. And so if I go to manager number 2, which is this one here, I can see that those numbers are the same. And indeed, it's the same again for manager number 3. So all 3 of those managers that are forming a single subnet overlay appear together with the same crypto. Now, if I was to go back to my sort of off-site manager, this one here, we can see that that's a different checksum, topology checksum and key set checksum. So that's not part of a peering arrangement. It's essentially external connectivity using IPsec. So let's just quickly remind ourselves of what this topology is looking like. I've got my app server in one cloud connected to a database in another. And what I'm going to do now is quickly show that the database can be moved from one cloud to another, and nothing else has to change within the application. So I'm going to do that by taking the database offline. But first, let's just have a quick look at the database itself. So I can see right now the state that I've got in the database, and I've already done the common keys bit, so let's quickly delete that out. And we can see that there's nothing left in the database now apart from that row saying primary DB. Now, normally state like this would be synchronized between the main database and its backup, but I'm not going to be doing synchronized state for the purposes of the demo, so you can see that the application's actually moved from one database to another. So let's just take this database offline, and what I'm going to do to achieve that is simply disconnect it from its VNS3 manager by stopping the appropriate service. So if I go to my application now, it's going to take a little while to time out, but eventually it's going to give me a screen full of errors because it can't talk to its database. Meanwhile, let's go and bring up the other database, and I can connect that into the overlay network by running a simple script. So that's going to take a moment to connect up, and let's just see what our admin consoles are telling us about that connectivity. So if I go to the first one, the one that the application server is seeing, at the moment it's not seeing any databases at all. If I go to the second one, originally the database was connected here. That should have gone away, and I can already see that the database connected into the third manager has started to appear across the topology. So connectivity has been re-established, and that's already propagated through. So if I go back to my application, it's still yet to time out, and it's just timing out there as we watch. But if I do a quick refresh, all is going to be back in action, and I can see that I've managed to fail over to my backup database. So that was a very quick wander through how we can use VNS3 to achieve a live failover from one cloud to another. And there's a number of different aspects that have been shown off here. So one is control over addressing by moving an address from one cloud to another. And under the hood, this is achieved by cryptographic identities placed into client packs. Another is control over security. So the entirety of this overlay network is secured using an SSL VPN, which means that all of that traffic isn't in clear text as it moves across the service providers' networks. In terms of topology, we've taken a very simple 3-tier application here and stretched it across a number of clouds. But that flexibility of topology is helped by this peering arrangement between the VNS3 managers, allowing that multi-availability zone multi-region, and multi-provider capability. So although we're using 3 different regions of the same service provider here, this could be 3 different clouds. And then finally, protocols. So we've not done anything particularly fancy with the protocols. It's just been sort of HTTP and regular MySQL database connections here. But within this overlay, we could run protocols like multicast, which can't be used elsewhere. So I hope this demo has been informative, and it should fit in well with the rest of the material that you'll be seeing about VNS3. Thanks for listening.